Okay, good morning. Yes, shall we start, ma'am? Yeah. In the last class, we have started some introduction about cloud computing. Yes, we have discussed several scenarios which motivates us to learn cloud computing. Like when we try to conduct a coding competition where we require a huge amount of processing capability for our systems. But that coding competition for 1 week, within that 1 week only, we require more infrastructure and more computational power, even storage we can consider. But these all are temporary. For that, we cannot go for an option called establishing entire infrastructure in our campus to conduct 1 week coding competition is not feasible, isn't it? So what can be done is we can suppose if some storage, some computing power, some sort of infrastructure is available to hire for some days, what you call some period of time, then we could able to get it for our purpose, and afterwards we can leave. So that infrastructure we don't need to build on our own, and we can survive or we can utilize for our requirement. This is the main motivation we have seen in the previous class. Yes, please respond now. Yes, do you remember it, this one which we have discussed now? Yeah. Next, now we will be seeing formally what is the definition of this cloud computing is. This cloud computing is an on-demand availability of computer system resources. Resources can be a data storage, or this can be a computing power. So it is basically the intuition of cloud computing. Formally, some experts are saying cloud computing. Experts are giving a different definitions for this same cloud computing in their own perspective, but more or less the functionality or the main idea is same. Here this is the famous definition from well-known researcher in cloud computing called Bhuya, Rajkumar Bhuya. He has given the cloud definition as cloud is a parallel and distributed computing system. Here in this particular definition, if you have any doubts, we will try to explore those things. Try to understand cloud is a parallel and distributed, both distributed computing system consisting of a collection of interconnected and virtualized computers. Yeah, here collection of some interconnected and virtualized computers that are dynamically provisioned and presented as one or more unified computing resources, like some set of processors, set of computing devices, storage devices, all together we are linking, okay, we are connecting, and we are performing parallel computing or distributed computing on top of the entire setup, and these resources how we will be utilizing is on service level agreements, SLA. This word is very important. SLA means service level agreements. Service level agreements in the sense how we will be establishing, how we will be utilizing the infrastructure. That can be a storage, that can be a computing power, or other things, other resources. How we will be utilizing, up to what time and up to what extent. Like computing power is there for some particular server or some particular system. We are having a computing power of like 100, let us consider. Then up to what extent we will be utilizing, like up to 20 we require. That such kind of agreement we will make with the service provider. Then accordingly we will be what you call paying for that particular resource. So that is part of a service level agreement, SLA. This agreement will be established through negotiation between service provider and service requester. And the consumer is nothing but service requester. There are two people: service provider, service requester are consumers. They will be negotiating themselves in order to utilize whatever the computing resources we have or storage resources we have. Those how we can able to utilize, how up to what extent and up to what level. These all things will be negotiated and will be fixed, and this will be presented in the document called service level agreement. So formally, what is the definition of a cloud? Cloud is a parallel and distributed computing system. It consists of several computers dynamically present in that particular network, and these resources can be utilized based on the service level agreements. Who will establish service level agreements? Service provider and service consumer. These two people will negotiate themselves and prepare service level agreements. This is what the standard definition for cloud given by Rajkumar Bhuya. He is Indian researcher in this particular cloud computing area, but he is a professor in Australian University. Yeah, another similar definition, of course, in some other perspective they will be saying, but these all are more or less the same. Just we'll go through once. Clouds are a large pool of easily usable and accessible virtualized resources. We can able to utilize these resources and dynamically reconfigured to a variable load. That is, if you need more number of systems, more computing power, then we could able to extend it, allowing also an optimum resource utilization based on pay-per-use model. Pay-per-use model in the sense how much ever we will be using, that much only we will be paying. Like whatever the example we consider, that coding competition, if you consider 1 week only we will be utilizing. For that 1 week, how much we need to pay, that only we will pay. Why? Because we are not establishing entire infrastructure in our campus for 1 week purpose. But whatever the infrastructure already available, that infrastructure we are utilizing. For that utilization we will be paying. So pay per use, in the sense, that is the. Now this is also again service level agreements. So this is another equivalent definition of a cloud. Is it fine? Yes. Yes, please respond. One. Yes, please respond. One. Yes, Nikhil.
Sir.
Yeah. Is it fine? Is okay this definition? Are you listening?
Yes, sir.
Yeah. Next, another definition, another equivalent definition. Here, clouds are hardware-based services offering computing power, network, storage capacity, where hardware management is highly abstracted from the buyer. Okay, like some set of systems we have, that in entire infrastructure is held by one particular organization. Let us consider we wanted to conduct coding competition by utilizing that infrastructure. For that, how many systems are there, how that entire system is being managed, all these things need not be disclosed to the user. What user will request is, this much computing power I need means, okay, we will provide. Such kind of agreement will be made between service provider and service requester. Then how that computing power is being offered, that is not disclosed to the service requester. Okay, that is nothing but abstraction. That abstraction will be provided to the buyer in such a way that how that entire computing power is being provided is not known. Okay, So buyers incur infrastructure costs as variable OpEx, and infrastructure capacity is highly elastic. That can be anytime extendable. That is what elastic means. Whenever we don't want that much infrastructure to be used, then we can minimize it. We can reduce it, and we can pay for that particular use only. Okay, this is what another definition of cloud. Like this, some other definitions also available. I will share this PPT, then you can go through it. Just now, more or less everyone will be saying the same thing, that we will be having some set of systems which are connected. Okay, and these all systems will be coordinated in order to provide some service to the service requester. Whenever a service requester and a service provider agrees for some particular terms, like this much usage or this much time, and for these resources we will be for this much of storage or this much of computing power, how much we will be pay, you need to pay, or how much I will be paying, something like that. Some negotiation will be done, then the service level agreements will be established. Accordingly, those services will be provided. Okay, this is what entire concept of this cloud computing. Is it fine? Yes.
Yes, sir.
Yeah. Here, this one more thing we will be seeing: a pay-per-use model for enabling available, convenient, on-demand network access to a shared pool of configurable computing resources. Some pool of computing resources we will be having. Those we can make use of those, and we can use pay-per-use. Okay, how much ever we'll be using, that much only we can pay, and this is more convenient and on demand. Whenever we require, then only we can request for it. Okay, what are those resources? Networks, servers, storage, applications like softwares. Applications are nothing but softwares, and services. These are the several computer resources which can be pulled together in order to provide a pay-per-use model in order to access conveniently. Okay, this is another definition that can be rapidly provisioned and released with a minimal management effort. Here, service provider will take care of how those all resources are being managed. Service requester, just he can request for it, and after agreement, he no need to worry about how those all things are being managed. That will be taken care by service provider, and just what he requires, this service requester has to do is just utilizing that infrastructure. That's it. This is what cloud is. So last final definition: data center hardware and software that provide services. Okay, this is simple thing. Cloud can be considered as a data center where we'll be having hardware and software that provide services. So another definition is cloud is more often used to refer to the IT infrastructure deployed on infrastructure as a service provider data center. This is another definition, equivalent definition. Of course, some detailed definitions we have seen, and these are some abstract definitions without giving more details explicitly. Okay, this is about the cloud. First, we have seen BooYah definition, then other definitions. Okay, next, coming to the cloud characteristics, pay-per-use. Of course, this characteristic we have seen in the definition itself: pay-per-use, and elastic capacity and illusion of infinite resources. How many resources we will be having at service provider side, we no need to bother. And elastic capacity, if you wanted to increase the computing power, increase the storage capacity, then we can anytime we can able to increase it. And if you don't want to use after some time, then we can reduce it. That is what the capacity called elastic capacity. In general, the similar kind of a feature we have seen, we have discussed. What is it? Suppose if one system is developed for 10 users, if we need to increase that one for 15 users. What is that fact? What is that feature called?
Scalability.
Yeah, scalability. So it is similar to that, but here we can able to shrink also. That is what the difference. Elastic capacity, in the sense we could able to reduce it whenever we don't want. That is elastic capacity. Next, third characteristic is self-service interface. What does it mean? Is some resources and some infrastructure is established as a cloud, and for that particular cloud, how those suppose 10 CPUs we have in the cloud, 10 CPUs, and some 100 TB of memory we have. 100 TB of memory we have at the cloud. Now, this entire what you call infrastructure will not be available in one particular hard disk. Definitely, there will be several set of several hard disks available at the service provider, but how we will be using those, that will be taken care by service provider. That means those interfaces will be maintained by the service provider, that is at the cloud. That's cloud side itself, that interfaces will be available. That is what the third characteristic called self-service interface. Next, here resources that are abstracted or virtualized. Of course, this is internal feature, like how many resources we have, how many how much storage capacity we have. These all resources will be hidden to the end user, that is service requester. Just he can utilize without bothering about the resources and all. Just that is what the characteristic, that is what should be the characteristic of cloud. Such kind of flexibility we should be able to create. One is pay per use, another one elastic capacity, and third one is a self-service interface. Fourth one is abstract or virtualized resources. Okay. Next, coming to the roots of this cloud computing, if you consider from mainframes to clouds, and this SOA, service-oriented architecture, grid computing, utility computing, hardware virtualization, autonomic computing, these all things are some roots from all these domains. Something contributed to become cloud. Okay, in the next slide we will be seeing. Try to understand one point here, that is in all these domains we are having some sort of roots which were utilized to introduce the concept called cloud. Okay, so now here the same point here in a more meaningful way it is represented. That is we are having hardware virtualization, that is multi-core chips we are having. In one particular chip itself we are having, like in one particular processor itself, multi-cores we established. Hardware virtualization, one core can be utilized for one purpose, another core, something like that. Parallel processing is allowed. All these things are part of hardware virtualization. Next, SOA, this we have seen service-oriented architecture, several services to be provided. Next, autonomic computing or data center automation, utility and grid computing. These all are part of a hardware, internet technologies, system management, distributed computing. These are broad domains. From these domains, all are several features which were introduced over a time, and by including all the some of the features from every technology, like from hardware virtualization, some features are included. Internet technology, some features. Next, system management, some features. Similarly, distributed computing features also included, and this entire intersection we can consider as cloud computing. I hope you understand the point. We are having roots of this cloud computing in any in all of these domains. Okay, from these domains some features we have extracted and made the intersection as the cloud computing. Okay, some features we will be utilizing from these all. That is virtualization and all we will be seeing now. This is about the background of cloud computing. Next, what are the services that we will be getting? This is this we will see in detail later, but this is just to give basic overview of these services. Software as a service. Here, some services we will be having like Google Docs and all. We are using. How many of you know about Google Docs? Yes, anyone knows?
All right.
Yes, sir.
Yeah, Google Docs. How we will be using? What is the advantage? Just what is the use of Google Doc? Please tell.
We can access the document from anywhere.
You can access anywhere. Okay, that is feature. Okay, what is the basic need of using Google Doc? What is the alternative for Google Doc that you try to do?
Getting data.
Getting data. Google Form or Google Doc? I'm asking. Google Document. See, in our system, local system, we will be having a software called MS Office, right? In that MS Word we will be having. By using that MS Word, what we can do? We can prepare documents, isn't it? That is what, in general, the usage of MS Office. Correct?
Sir.
Yes. Yeah.
Yes, sir.
Now, the same MS Office or same document we can able to prepare without having that MS Office software in our computer. Yes or no?
Yes, sir.
Yeah, that is what the service. Without having that software in our computer, still we could able to create a document. That extension can also be .docx. Can you have you observed anywhere? Anytime this Google Doc have you used? Yes or no, ma?
Yes, sir.
If you have used, then we no need to do. Yeah, see, this Google Doc is a very good example for treating software as a service. That software they are providing over an internet, that is cloud. So that service they are providing. Next, platform as a service. Platform as a service in the sense some sort of runtime environment we will be getting to execute our programs. That is platform as a service. How many of you know about this Hadoop? Windows Azure or Hadoop? How many of you know? Anyone knows about Hadoop?
Yes, sir.
Yeah. In that, what we'll be having? What are the main components of Hadoop while implementing it? We'll be having two modules, right? Map.
Yes,
Map
sir.
and map module will be having, then reduce module, map reduce model. Have you gone through this particular term, map reduce? Okay, fine. That is not required for our discussion. Just if you know it, then I can relate it more. That's why. Yeah. Here we will be having some sort of platform established in order to work out whatever the required task to be done. Like suppose if we wanted to execute some program, for that we require a setup called compiler is needed. This kind of IDE is needed. Some compiler is needed on top. Such kind and database needs to be linked to this. Such kind of requirements are there. This entire platform is provided as a service. That is platform as a service. Understand? This anyway, these all points will come again in more detailed way. Just you understand here, software as a service is nothing but providing a software. Platform as a service is providing a platform. A simple example is, if you wanted to run a program where we require certain compiler and IDE, let us consider, then it has to be linked to some database as well. This entire thing we can consider as a platform. That platform we can able to get as a service by using. Next, third one is infrastructure as a service. This is quite natural. Infrastructure as a service in the sense like whatever we have seen. Storage, if you wanted to utilize for 1 week, then that is infrastructure. For entire storage, whatever will be will be going to store in the next 1 week, we require huge amount of management. Like it's like some servers we require. This entire setup we can consider as infrastructure. Some servers will be having, storage will be having. These are how these servers are, these storage devices will communicate, and all some networks we have to establish. All these things are part of our requirement. That is provided as a service. That is nothing but infrastructure as a service. Example here, Amazon EC2. I think this you might be knowing. EC2, Amazon EC2 is one cloud platform where we can able to get infrastructure as a service. And other examples are RightScale and vCloud. You can explore this. So these are the 3 different services which we can able to get out of cloud environment. One is software as a service, platform as a service. Last one, infrastructure as a service. Yes, is it clear? Yeah, have you got a basic idea of a cloud and what are the applications characteristics of this?
Yes, sir.
Yeah. Now we will be considering this last one. First, we will be discussing about the last one, that is infrastructure as a service. Yes, this is very much intuitive to our discussion. Let us see this virtualization. Infrastructure as a service. Virtualization. It's like we'll be using our system only, but with our system we could able to compute a very big task. We could able to complete a very big task where for which we require more infrastructure. Okay, so such kind of illusion we could able to create by using virtualization concept. Okay, so let us see what is meant by virtualization. It is like we'll be having several technologies under this virtualization, where we will be providing some sort of abstract environment where we'll be having some hardware resources, software resources in order to run some applications. Okay, what is meant by virtualization is nothing but providing some abstract environment which consists of hardware resources, software resources in order to run applications. Okay, this is what virtualization definition. Next, now if you consider why we need to go for this virtualization concept. Now the question is why we need to go for this virtualization. Here, first, increased performance and computing capacity. Nowadays we are having a system with i5 processor, i7 processor. Yes or no? i5 processor, i7 processor. How many cores we will be having? Yes, I think in the first class or second class we have discussed about dual core processor. Did we discuss that or not? Dual core processor, core to duo processor. Yes or no? Yes.
Yes, sir.
Yeah, in that Pentium 4 processor will be there. Dual core processor in the sense, those kind of Pentium 4 processors will be having two cores will be having. So it's like having 2 processors in one particular chip. That's it. Okay, 2 processors will be having. So computational power is being increased, yes or no? Now, earlier in one particular system, we will be having P4 processor. Afterwards, dual core. So the computing capacity is doubled. Afterwards, core to duo. Core to duo in the sense, whatever the dual core processor we are having, those kind of things, 2 we are having. Like, it is nothing but 4 Pentium 4 processors. Like that, afterwards i3 processor, i5, i7, like this, the computing capacity is being increased a lot. Yes or no? Yes.
Yes, sir. Yes, sir.
Yeah. Now, if you consider what this is one observation, increased performance and computing capacity. This is one observation. But out of this observation, what we can understand here is what we can deduce is, it's like earlier when you consider your first year. Let us consider when you consider your first year, what you used to do in your computer. You could do like C program execution. This I'm considering some good things. C program execution. Second one can be browsing internet. That can be for getting some material or some other such kind of activity. Third one can be watching videos. Fourth one can be listening music. These are the 4 things we can consider in first year. Now, in the final year of your BTech, what are the things that you are doing? Are you
Listening online
executing?
classes.
Yes,
Listening online classes, sir.
listening online classes. Okay, watching videos we can consider in the same way. Of course, listening. Okay, next, executing programs. Of course, not in C, maybe in Python or maybe in Java or maybe some other language. Next, browsing internet. Definitely, you will be doing. Of course, not only for getting the material, for some other things also you will be browsing. Next, watching videos you will be doing, listening to the music. Any other things? Okay, let us consider these are the things. Now, these all things can be done with the previous processor which were there in 4 years back system. Yes or no? Same things we could do with the 4 years back system also. We no need to have advanced system in order to pursue these things. But over a time, computing capacity is being increased. That VLSI technology we have integrated into our system. So automatically, what will happen is computing capacity will be increased. Okay, not without updating it. Some new systems I am saying. So it is updated. Now, although we are having more computing capacity, are we utilizing it? Definitely not to 100%. Yes or no? According to the developments, we have got new systems or advanced systems, but we could not able to utilize 100%. That is what we can consider. That is nothing but underutilization of hardware and software resources. This is the deduction of first observation. Computing capacity or performance is increased, but underutilization of hardware and software resources. So now, if you consider the case like the software industry, you consider software. In software, there will be working hours like from 9 to 7 o'clock, morning 9 to 7 o'clock. So 9 to 7, some systems, all the systems will be on, they will be working. Afterwards, after 7, all systems will be turned off. or you consider some office, government office you consider. So many systems will be there. People will come morning 9 o'clock and will work up to 6 o'clock, and they will be turn off all the systems and will go. So more than half of the time, all the systems are hardware and software resources are being idle. Yes or no? Yes. Please respond. Yeah. Now with this observation, what we can propose? It's like whatever the resources we are having, if those resources are utilized for 9 hours by some people, then remaining hours we can utilize. Remaining computational power we can utilize. Remaining storage capacity we can utilize. This is the motivation to introduce the concept called virtualization. Understand? Similarly, another intuition is lack of space. Lack of space in the sense it's not storage space, it is a physical space. Like suppose if you need to establish some infrastructure at your home where you need to provide very big server and cooling material for that particular server and some interfaces related to that server. These are all things you need to establish in the sense you need to have some proper space at your home. Similarly, whatever the huge infrastructure which we need to require, we need to establish in the sense a huge infrastructure, physical space we require that may not be available for all the people, that may not be possible for all the people. That leads to the introduction of the concept called virtualization. Okay, this point you will be understanding after discussing the next one. See here, greening initiatives. Greening initiatives in the sense you can guess here the point suppose for our department, let us consider for CSE department we require some infrastructure like some 3 servers we require, and accordingly some terminals we require, and in order to make proper temperature we need to have some 10 ACs and all. Okay, this is the infrastructure that we need to have. Next, similarly, EC department requires AAA department. Like this, everyone requires such kind of infrastructure. Then what will happen is automatically that that will affect what environment. Yes or no? That is what called greening initiative. Because of this greening initiative, it is not advisable to keep on establishing their own infrastructure whenever required. That leads to proper utilization or efficient utilization of the infrastructure which is already available. That is what the intuition for virtualization or motivation for introducing the concept called virtualization. Now coming to this lack of space, people will be establishing these infrastructure things, but they may not have physical space available. Then they could not maintain safety measures without affecting the environment. This is another motivation for introducing this virtualization. Next, administrative costs will also be increased. Why? Because so many servers will be there, some security we have to maintain, and how those servers are being managed among several users of those servers. All these things will come into picture, and automatically administrative costs will be raised. So these are the main factors which motivates us to go towards the virtualization. What is meant by virtualization? Providing some abstract environment with the hardware and software resources. We will be able to run some applications on top of it. That is what virtualization. Clear? Yes?
Yes, sir.
Yeah. Now here you see this is the virtualization reference model. Here we are having three different layers. One is a guest virtualization layer, second one, third one is host. If you can see the things that we are having at each and every layer, here host is nothing but actual physical things, whatever we are having, that is physical hardware. Servers we may have, and physical storage we may have, some disks and all will be having, some tapes, disks, those kind of things we'll be having, and networks. Here we can have switches and routers, all these things. This is physical establishment. Now coming to the first one, that is guest. Guest is nothing but service requester. This service requester will try to utilize whatever the hardware which is present at the host layer through this virtualization layer. Okay, so from this guest layer we will be having just user interfaces, like from terminal how user will be able to give the instruction, so that that can be executed at server in order to update the storage. These all things will be taken care by virtualization layer. Here what is the need of this virtualization layer is, this guest may require several, or you consider one small thing. Host is one single entity. You consider host is single entity. There are several guests. Each guest will require their own specifications. Like one may require to use Windows system, one other may require to use Linux system, other may require to use Mac OS or something like that. In order to work out all those things on the same hardware, we require virtualization layer, where we will be having some sort of interface called software emulation, where we will be having some converter in order to accommodate whatever the needs required by the different gates. This is what virtualization reference model will be having. Three layers: guest, virtualization layer, host layer. Host is nothing but physical things. Guest is nothing but it's purely virtual. Just they will be giving requests through terminals. That's it. Virtualization layer plays major role here. That is how these requests can be processed or serviced by using software emulation. This is what we do. Now coming to this, what is the initiation for this kind of things in programming aspect? Like how many of you know about applets? Applets. Do you have idea about applet, man? You didn't heard about it?
Heard about it, sir, but don't have a clear idea.
Okay. Where you heard? In which subject?
Java.
Java applet.
Okay. Yeah, Java applet. Java applet in the sense, it will run on client system itself. Although it is a server-side program, that is server-side, will be having applets. Those applets, whenever we request, then that will be downloaded to client system, and at client system we will be executing. Understand? But it will give the intuition that we are executing at server side. This is basic root for this virtualization concept. After actually in 1995, this Sun has introduced this. Afterwards, this Microsoft introduced .NET framework. You know it, right? .NET. Yes, .NET framework.
Yes, sir.
Yeah, the .NET framework is developed in order to compete this Java applets actually. Okay, they have given the .NET framework as a substitute for this, and they have integrated so many things in it. Not only this applet functionality, so many other things also they have included, and they developed in order to provide that virtualization concept. Like whenever we require to make use of that Java applet that will be downloaded into our system, it will be executed, but that is client-side program. Similarly, .NET also will provide such kind of environment. So these all are interfaces, that is virtualization layer will be having such kind of things in order to service the requests given by this. Okay, afterwards of course Python and all came into picture, and these Python also provides such kind of interface emulation. And I will try to give another example. Like if you open run in Windows, run and CMD, what you will be getting? Run CMD. Then in the run, if you CMD or command, what you will be getting? Command prompt. What is it actually?
Terminal.
Terminal. Any other answers? Of course, it's not wrong, but it's I am expecting another answer. Terminal for what? Okay. Let me ask another question, and then you can understand. See this, now we are almost everyone is using Microsoft Windows 2010, right? Yes, Windows 10, right, everyone?
Yes, sir.
Yeah, before that what was the operating system by Microsoft? Before that, before Windows 10, what was that?
Windows 8.
Windows
8.1.
Okay, 8.1.
8.1.
Before that?
Before that 8.
8. Then
7.
7. Yes. 7. Vista also. Yeah, Vista is also there. Yeah. Before that?
XP.
Yeah, Windows XP. Of course, Windows 2000 is there, but XP you can say as a more popular one. Yeah, XP. Before that, before XP,
Windows 2000, Windows 98.
even XP is around 98 only. Yeah. Okay. Fine. Next. Before
Pentium.
that.
Pentiums.
Huh?
Pentium.
Pentium is processor. I'm asking about operating system.
Windows Vista, Windows 2000, Windows 98.
98. Before that, from Microsoft, right? These all. These all operating system which we have listed, these all are from Microsoft only. So before this Windows operating system, actually Microsoft, from Microsoft only, we were having an operating system called DOS, disk operating system. Have you heard about it? MS-DOS. Yes.
Yes, sir.
Okay, MS-DOS. What we used to have in that particular MS-DOS is we will not be having this Windows environment. Why that name Windows is like every application is considered to be as a window. Yes or no? Like if you open folders, that is a window. If you open command prompt, that is a window. If you open like this, what you call some file, that will be considered like a Word file or Excel file or a PowerPoint or even IDE or compiler, Notepad, WordPad, Paint. Everything is a window. Yes or no? Yes.
Yes, sir.
Yeah, Windows operating system means everything will be considered as a window. Similarly, in a disk operating system, what we used to have is like Linux. We will be having, right, terminal. If you wanted to open a file, then we have to type a command. Then according to the command only, we have to open, or we have to read, write. All these things we have to do with commands only. Similar way, we will be having in Microsoft version called DOS operating system, that is a disk operating system. We will be having such kind of environment, like creating a folder means we have to use make directory, something like that. Such kind of what you call commands will be having, like cd space folder name you will be giving, right? Change directory, make directory, md, like this. These all are executed based upon the commands. Such kind of environment we cannot we have improved, of course, for our flexibility we have improved and we have went to Windows. But now if you wanted to execute some particular program in DOS operating system, okay, one command if you wanted to execute in DOS operating system, that is the requirement from guest. From this guest, the requirement is I wanted to execute one command in DOS. Then this software emulator will create one environment where we will be feeling that actual environment, that is DOS. Then it will execute and will give the result. That is the beauty of this virtualization layer through this software emulation. Got it? Or I can give one more easy example, like just 1-2 minutes, man. Python, you know, right? Python. What is the current version of Python?
3.8.
3 point. Okay, some 3.x, let us consider 3.x is the latest version. Now I wanted, I am having very good application, but it is developed in Python 2. Okay, Python 2 is there. In that I have very good application. I wanted to utilize that one. Then in my system Python 3 is there. I cannot run that Python 2, right? So what can be done? Then this emulator, this software emulator will create an environment where we will be having the Python 2 compiler, and it will execute. It could able to execute. It could able to service for that particular Python 2 program. That is called software emulator. Got it? I hope you got some kind of motivation to about this software emulation. Yes.
Yes, sir.
Yeah. So this is virtualization reference model. In the next class, we will be seeing some other related things. You please enter your roll number in the chat box and can leave.